Yeah, so thank you so much for joining this session today, especially considering there are too many sessions going on right now. It's kind of interesting because this was my last conference in 2020, and now it's my first conference again after the pandemic, so all of you are very welcome. And it seems it's like, I was not even sure I was going to feel here because it's kind of like the first presentation I make to audience in a very long time. So I hope everything goes okay. Yeah, they're giving me the big room too, right. So my name is Roberto Cortez. I work for Red Hat. Before that, I was doing a lot of other stuff, but mainly now I work in Quarkus. So today's session is not gonna be about Quarkus. I'm gonna talk about other stuff, which is OpenTelemetry tracing. So I hope that you'll find your time very worthwhile. But anyway, if you have any other questions about OpenTelemetry later or Quarkus, feel free to reach out. I'll be happy to help. Yeah, so our agenda for today, I'm going to have a lot of demos to show you later, so that I'm going to try to, I'm just going to put a couple of slides to introduce the topic to you, and then I hope to go quickly to the demo because that's the most interesting part, I believe. But anyway, I'm going to try to explain a little bit what's distributed tracing and why it's important in today's architectures. Not only microservice architectures that we are now used to do, but it's also useful for monoliths as well. And then, of course, talk a bit about what OpenTelemetry brings up into the table to help us develop better applications where we can understand what's going on and that we can figure out where the issues are. Okay, so who's here developing microservices? Okay, pretty much all of you. Or if you don't, maybe you're trying to develop them in the future. So for me, there's not much difference between a microservice and a monolith, right? I mean, they're just, I'm not going to say the word, but I guess you pretty much understand what they are, right? And the point is, I mean, the problem with microservices these days is they sell you as like this silver bullet that's going to solve all of your issues, but unfortunately, that's not the case. It's actually going to create a lot of other problems, right? You have to put a lot of stuff around your architecture to make sure that you're able to figure out what's going on. So what we can figure out about this? So there is a lot of additional complexity about when you're doing these kind of architectures. It's not only related to microservices. Actually, a monolith have its own goals, right, or its own challenges. Now, the problem with this is, now think about this for a second. You have your system, that's great, you build your application, that's awesome. Now you're gonna call whatever endpoint or entry point to your application. It doesn't have to be a REST endpoint. You can have maybe a CLI application, or you can maybe have an asynchronous job that's gonna run. So when you have a lot of services involved and something goes wrong, what are you going to do about it? How do you figure out what went wrong, right? So you have to be prepared to answer these questions, which is, who caused it, right? When did it happen? And where in the request, right? Now, maybe this is not very visual to you, but let me show you something very interesting. So here is like, the slide is not, problem is the definition is not that great. But so I went to the Amazon website. I wanted to buy a PlayStation 5. Unfortunately, they're sold out. Well, that was like a few months ago. Maybe they have it right now. And then I put like the network that was involved just to build the web page for showing a product. And this is for PlayStation 5, but I'm pretty sure that every product will display the same things. And all of those things that you see over there on that screenshot, I mean, probably you're not able to read them, but all of these are like requests to external systems just to build that web page. Now, what if something goes wrong? Do you know exactly what went wrong? What if those systems call each other or call something else in the middle? Do you know what happened? Let's see another example. So this is probably one of my favorites. So this was actually posted by one person from Uber, and this is the graph, well, probably outdated today because this was posted, I think, like 2019. But this is the diagram graph for their microservices. And this is just, so if you see like the pink arrows, this is just one call that they make to one of their applications. Well, you see all of these dots, right? They all connect with each other, and they basically, depending on whatever request or whatever entry point you have into your system, they may be called or not. But the point is, if something goes wrong in the middle, do you know what happened? Right? It's tricky, it's hard. So these take us to what we call distributed tracing. So the idea with distributed tracing is that you want to track the progression of a request. And when I say request, we're not talking about HTTP requests, it's just a request in general. This can lead to multiple events. Sometimes you're even calling a synchronous event, right? And the idea is that you're also able to traverse boundaries. When I say boundaries, let's just say, pick up a very simple example. So you have like a bookstore where you want to buy a book, and sometimes that involves putting your credit card information. That credit card information has to be validated somehow, and then you have to take the book out of your inventory, so you have like a database involved. So you have a lot of interactions over here, and you have to traverse them all to make sure that you're able to record everything that happens, so when things go wrong, you're able to figure out what happened. Now, don't get me wrong, you're not only doing distributed tracing to figure out what went wrong, you can also use this information to optimize and figure out what you can improve on your application. Let's just say, for instance, you have one part of the service that have poor performance. So with distributed tracing, you're able to figure out, okay, I'm taking too much time over here, so let's try to improve that. So it's not only about figuring out mistakes or errors, but we also can use it to improve your system and your application in general. Now let's introduce a couple more other concepts, right? So distributed tracer usually, one of the main concepts is what we call the tracer. So the tracer is something that happens across all your system, which contains a couple of more things that help you spread the information around the entire application or system as well. So what you have is what we call the span context. So the span context is what we are going to use to propagate all the information across all the jumps that your application or system can make. The root span is something that we create when we do the entry point into your system, right? So there's nothing, you have to start and create something to be able to propagate. Then you have this notion of parent and child spans. So these are like the individual records that are going to create every time you do a step into your system. And then when I say we have this parent-child relationship, is because not everything is unique, right? So in the sense that you can have a system that can span a lot of other calls to other systems in the same place. So that means that we have like a parent and child relationship. And of course, this is not possible if you cannot propagate what will happen, right? So if for some reason the system stops the propagation, then of course you're only going to have tracing until that point, and then for the rest of the system, you're not going to be able to see it. So ideally, what you want is an application that's able to propagate that properly. Now, expanding the example that I gave a little bit earlier about the bookstore, this is just like a little bit of a visual of what a trace of buying a book could be. So don't get too stuck into the example I put over here, but just say that you want to buy a book, right? So I'll go and buy a book, go to my website, I put my credit card information, so I have to process the payment, right? So we usually process the payment, then I have to look up the credit card to make sure the credit card is valid, right? So what happens over there is, so the buy book is just, it's your entire trace, right? And that trace is going to be composed of like multiple spans. So multiple spans may or may not represent the operations that you build on the system because they can contain like, now it depends on what you want to do because they can be more detailed or not, but this is just an example, right? And then let's just say I put my credit card information, that's done. So now I have to move to another system, and you can see like there are like three different traces that are, sorry, three different spans that are created over there, which is ship and label, create invoice, and update stock. So all of these three can actually happen in parallel, right? after I process my credit card information. So I create the shipping label, then of course I create the invoice. Those are not dependent in any way. And then I present the stock. And notice that all of them are like different lengths, right? Because they can take different time to complete. So that's how they are represented in the context of the span and the trace in general. Now, in there you see that there's like a little bit delay, so they're not really joined with each other, because once the book order is in, it may take like a couple of days for the book to be shipped, right? But that's still part of the same action or the same entry point or the same request that you did. So that is not about like a transaction. Don't think about this as a transaction in the poor sense of a database thing, right? But it's still part of the action that the user initiated on your system, right? So you still need to track all of that because, well, maybe the system was able to process the payment and update the stock, but then it failed when the shipping order happened. And maybe it failed because it was missing information of one of the previous steps, right? So you still have to track all of that until the end. So in the end you have a couple of other more spans, which is like shipping order and then tracking the order, and then once you actually do the shipping is when you're going to deduct the credit card. So you see there is, on a single action, as simple as buying a book, you have a lot of interactions with your system. And if you notice, you may even have interactions with external systems, let's just say like the credit card provider or even the shipping provider, right? So ideally, what you want is to propagate the context across all of these boundaries to create a nice history on what happened with that request. So that takes us to OpenTelemetry. Now, OpenTelemetry, maybe you haven't heard about OpenTelemetry or using it right now. So a few, okay, so maybe half the room. Okay, so let's talk a little bit about OpenTelemetry and what it can do for us. Now, has everyone heard about OpenTracing or OpenSenses? Just a couple of people? Okay. So OpenTelemetry is actually a merge between older projects like OpenTracing and OpenSense. So we're not going to go too deep on that. But the idea with OpenTelemetry is it provides telemetry data. So when you think about telemetry, it's about collecting information about your system, putting it somewhere, and then you can take decisions on that and figure out what went wrong or what's happening with your application. Now, OpenTelemetry itself is not only about tracing, but in this presentation, we'll only focus about tracing because I thought about this, and if I was going to talk about everything about OpenTelemetry, then we will not have enough time. So I've tried to focus everything on tracing part. So OpenTelemetry is also about metrics and logging. So hopefully in the future, I'll have sessions about this as well. So for now, let's just focus on tracing part. And OpenTelemetry provides a way to instrument your applications. It can be either manual or automatic. So in the sense that, for instance, you can even pick up an application that you already wrote and put OpenTelemetry on top of that without changing a single line of code. And you're able to get a lot of the data that I'm talking about. So, I'll show you how you can do that in some of the demos that I'll have for you. Finally, there is another concept which is called collectors. So the collectors, what they're going to do is they're going to receive the telemetry data, and then you can push this data into things like Jaeger, Prometheus, Grafana, wherever you want to collect that information. So that's pretty useful. Now, this is just like a sample schematic on this could work, right? So you have your backend application. You can have like multiple backends, of course. And what you have an application that has an OpenTelemetry library, right? That OpenTelemetry library is going to collect all the information. It's going to send this to the collector. Or you have a collector service that's going to collect all this information. And in the end, well, it just get pushed to whatever place you want. So in concept, it's pretty simple. So now you may ask, what can I trace? Well, virtually everything. So you can trace things like network, including HTTP, both client and servers, right? Databases, RPC calls, for instance, gRPC, messaging service, queues, publisher subscribers, things like Kafka, ActiveMQ, whatever you want to trace in that space. You can even trace exceptions coming from your calls, from your code. So there is a lot of things that you can do. The OpenTelemetry APIs and implementations already do a lot of these things for you, but of course, you can also implement your own. Now, one of the things that I always recommend for you to start, if you already have an application and if your library doesn't support this yet, is going with the agent instrumentation. Because, why? Because it's very easy to set up and provides you already all the telemetry data in one go. So it's pretty much an out-of-the-box solution. You just configure the application to set up is using a Java agent. So what's going to happen is when you set up the Java agent, Java is just going to instrument your application for you at start. So of course, there's going to be a pay price for that. But I mean, one of the interesting things is that if you're running on a cluster with multiple nodes, you don't have to do them on all of them. So you have to figure out what works best for you. Now, this is limited for the libraries that are supported right now by OpenTelemetry. But if you look into them, they do support a lot of stuff. So they support things like Spring, other application servers like Wildfly or Liberty, other things like even Jetty, multiple HTTP clients, Kafka connectors. So you name it. They have like I can't remember all of them, but if you go and look into their website, they have a bunch of them ready for you to use. Or you can, of course, create your own. So that's one way to do it. A second way is you go with library instrumentation. So OpenTelemetry also provides the framework library implementation as a standalone. So you just like a jar that you add as a dependency to your project, and then you can do it directly on your application just by adding that library. So the only difference is they are not using the Java agent. And if you want to have like specific ones, then you'll just have to include all the libraries for each aspect of the application that you're using. So you have many for them, like you have one for Quarkus, you have one for Spring. It also integrates with the agent, which is quite nice. So if the agent doesn't have an integration for a particular one, you can actually mix both, and you have like OpenTelemetry from the agent. You have instrumentation from the agent, and then you have instrumentation coming from the library, and they actually connect with each other. So they are not conflict. So the OpenTelemetry API is quite smart enough to see, okay, there is this telemetry coming from the agent, there is OpenTelemetry coming from the library. They're gonna like merge both, and then you have like a consistent information coming from your application. Of course, there's also the manual option. You can access the OpenTelemetry API, and then you can, of course, include it on your app. And you can add your own attributes into the span. You can create your own spans and do whatever you want with it. So this is a little more intrusive because it requires you to actually modify your application to do that. So in some cases, it makes sense. But that's something that you have to evaluate if you want to do it in this way. So sometimes it's useful, for instance, if you have like some sort of like a filter to do authorization, and then you want to also add into the span whoever is authorized. I don't know. There are like some use cases that you want to use. But you have this option as well. Exporter. So the exporter is quite interesting because OpenTelemetry also created this OTLP, which they call the OpenTelemetry protocol. And a lot of the things that you use for monitoring, they do support this protocol already. So they're able to collect or receive the data coming from OpenTelemetry integrated over there. So I mentioned this before, but basically things like Jaeger, Zipkin, and Prometheus, they already support OTLP. And then you can push telemetry data directly to those tools, and you can get the things coming from your system. Okay, so I'm pretty much done with the slides. Sorry, probably took a little bit longer, and let's go with demos, which are probably the most interesting ones. Before we go in that, do we have any questions? Okay. Yes? Sorry? Okay, so the question is if it needs to be installed in a VM, right? No, you don't have any, you don't require any installation. Yes, so basically the question is if I have an agent that I can plug in the app. Yes, that's exactly it. So that's what I'm going to demo right now. And you're going to be able to see it. Okay, so let's go over here. IDE, not this one yet. I'll have a couple of more elaborated examples, but for now, I'm just going to use this very simple one. So in here, I just have like a very simple application, which is like a REST endpoint, which generates a number. That is that it generates like ESPN numbers for a book. And you can see probably, I mean, this is just using Jetty and JAX-RS. I could have done this in Spring as well, so also it will also be the same. But you can see here, there's nothing really out of the ordinary. So it's using JAVAX packaging over here, so you don't see any OpenTelemetry. Well, the OpenTelemetry stuff you see is just the package name that I just created. It's not like the actual API. And if I show you the POM file, well, you're gonna see some OpenTelemetry stuff over here, but you don't see any OpenTelemetry libraries. What you see is the configuration for Maven dependency, which is going to use the agent to plug in into Jetty to add telemetry information. So let's start this up. And let me, I think I probably have some stuff running over here, so let me just shut that down. Okay, so let's go here into this agent. And oops, I'm just going to start here a Docker compose file. This doesn't have anything. It's just starting up the hotel collector and Jaeger, so we can collect the data and then display it on Jaeger. So it's running over here. Let's start this in detach mode. And now I'm just going to run. Are you able to see this properly? Want me to increase the font? Is it okay? Okay. So now what I'm going to do is I'm just going to run this application with Jetty, and I have a profile which is setting up with the agent. So basically that's what I have over here in these, where is the profile here on Maven? Sorry, agent. Okay. So yeah, this dependency plugin over here. And now Jetty just executed as normal, right? So now I'm just going to do a couple of curls here. This now generating a couple of numbers from my app, right? And now what I can do is let's go here to Jaeger UI and let's see what we find. So there is this number API that showed up over here, and I do find traces, and now you can see that this number API, so this is kind of like a very similar with one of the slides I showed earlier with when you were buying the book. So now you'll see there are like a couple of actions that were recorded by OpenTelemetry and are being displayed on Jaeger. And the interesting thing is that I haven't really changed the code of my application. The other thing I did was just plugging the agent, and now I'm already collecting some information that I'm putting over here. So let's see what happened. So now I'm able to see that it called these numbers./generate endpoint. This actually was collected by the OpenTelemetry Jetty extension. And well, then I'm able to get all of this information, right? I'll see, well, that was the endpoint that was called. That was the port that was being used. So that's localhost 8080. This is the span kind. So there's some information going on over here. And then I can even move it over here and see, okay, so this actually was being the fully qualified name of the class that was being called by the REST endpoint, right? So one of the interesting things over here is that I'm going to show you also later is just by you looking into the OpenTelemetry that's being collected, you're already able to retrieve some information from your app. One of the interesting things is, even if you don't know the app, you already know, oh, that REST endpoint calls that fully qualified class name. So then you're able to go into the app, even if you don't know the code, then you at least know, okay, this is the REST point that's being called, it's right here. So then it actually also helps you navigate the code if you don't know it. So this is one of the ways to do it, and it's one of the simplest ways. I mean, this is a small example, but it works with any kind of application, no matter how big it is. It's just an agent, so it's not going to change anything in your code. Just going to work out of the box. Okay, so let's kill Jetty. Let's clear Jaeger. And now I'm going to show the library option. So let's run it like this. So now I'm not running with any profile. So I'm running here now another example. This one is called, that I call library. So this is the exact same app. So you have the exact same REST endpoint. But now I'm actually using a couple of things from the APIs of OpenTelemetry. You see here with span. So now you see there is actually coming from the OpenTelemetry API. And this is quite interesting because now you can annotate your methods with span, and that means that those methods will also be put it on the telemetry data, so you know that that method was called in that particular action. So if I do something similar over here, so let's go now in here, let's do a couple of curls. Let's go to Jaeger. Let's go back, find trace. Oops, let me go, probably should have started. Apparently I haven't started Jaeger. Okay, let's start that. Run. Couple of endpoints. There you go. Okay. Now I should have something here. Not yet. Something's missing. Not sure why. I'll probably change something over here. Well, that didn't work, which is unfortunate. But let me start this with the agent as well. I have to figure out why that didn't work. Okay, but this one I know that should work. Okay, so this one is already there. Okay, find traces. So now remember, you've probably seen 2 traces on the last example. Now you're seeing 4. And the 4 is because I'm combining, so while the library demo didn't work, I have to figure out why. But the combining of the agent and the library actually worked. And now you still see the same spans that you've seen earlier by the OpenTelemetry Jetty, right, invoking the REST endpoint. But you also see some coming from this library that I just wrote called small-y OpenTelemetry. And if I show you here span new, you're actually going to see that using this number resource, I inject a tracer, and then I create a span, and I call it span.new, and then I set a couple of attributes. So this is how the API actually works if you want to create your own spans. And you can actually see it right here. So you see it's like span new. If you go on the tags, you'll see that TCK new key, TCK new value, just like some random stuff that I wrote. That's basically what's over there. So you can collect your own, that's the way you can collect your own spans and put them on the app. And now you see, okay, so I call this REST endpoint. That call that tracks the REST, which call that namespace, which is that fully qualified name of the class. And now I created this TCK new value that's being recorded over there. And now remember that with span annotation, which is on number being get prefix. So this is just the simplified name. And basically it's over here, number being get prefix. So I know that that was called as part of of my request. So let me see, we have 15 minutes left, that's great. So those were like very simple examples. So let's go to a more tricky one, or a more complete one. So I talk a little bit about the example of the bookstore. So of course, that was actually what I wrote to show you here. Well, not elaborate because I don't have a connection here to like payment gateways, but we'll see another aspect of it. So let's kill this. Smaller OpenTelemetry. So let's kill Jaeger. Let's start with a fresh instance. Over here. Okay. Done. And this one is already, it's done with Quarkus. It could be done with anything else, doesn't really matter. So let's start this up. And now I'm going to try to do a couple of challenges with you, in the sense that I'm not going to show you any of the code of this application first. You're actually going to look into telemetry data and try to figure out what the application is doing, and then trying to link that with the actual application code. Okay, so now I have here, my application is starting, right? So let's look. So what we have here now is I have this Swagger UI. So I have like a couple of endpoints. Okay, I have no idea how my application works. I'm just looking at the endpoints I have. So let's try to create a book. All right, so let's authorize here first. Authorize. Let's try this out. Let's execute. Okay, so let's see. So it gave me a 201. I created this book. So it's called, the author is myself. I created like a Quarkus in action book. Doesn't really matter. Now let's go to Jaeger. And let's look what we have here. So book API. So now we see 9 spans. It's actually quite large number of spans. Let's put a couple of more. There is like a trick over there. Actually, it's going to show a little bit less. Okay, so 9. Now that's 4. And now there's 7. Now, did you notice that? So the same trace, which was 4 now got 7. So one of the interesting things that I haven't told you yet is each trace creates like a UID that gets propagated across the entire calls that you make. And it doesn't matter when a span is created or not. It can be created like 10 days later. Once that is created, because it's the UID, once it gets into collector and the collector sends it to Jaeger, Jaeger says, oh, this is the same UID of this trace. So it's going to associate it all together. So then you see the entire history of what happened. Right? So that solves that problem that I mentioned earlier, where the shipping label may take like 2 or 3 days later, and then you may have lost the context, but you actually didn't. So one of the things that the propagation does is use this unique ID to propagate the information, and once it gets back to your monitoring system, it can merge all of that together, and you can see all the history over there. Now, let's try. Are you able to see this properly? So let's see. There is a books call on a books REST endpoint, right? We can see this actually coming for Quarkus OpenTelemetry. We got 201. That's what we got on Swagger UI. So that's correct. That's fine. And now let's see what else happened. So we see there's a ASP.NET generator fallback.handle. So that seems like a method call, right? I haven't even showed the application, but that's already giving some clue on what's happening. Right, so we go and see some tags. So this coming from Quarkus as well, this OpenTelemetry, right? Now we see again books fallback.send, and now we see this actually coming from reactive messaging Kafka. What's happening over here, right? So we know that apparently when we try to create the book, this ends up in some sort of Kafka queue, but we still have no idea why. But we know that the destination was called books fallback. It's right over here on the message and destination of Kafka, right? And the Kafka is a topic. Okay. Then apparently we also have another endpoint that got the books fallback receive. This was the consumer of the Kafka client, which got the book. Okay. And now we also have like this ESPN generator fallback ESPN. And finally, we see a couple of selects here on the database. And finally, an update. And we see like the query that's being executed for that book. Now, does anyone have any idea might that happen on this without even seeing the code? I was just looking to OpenTelemetry. It already gave me a lot of hints at what might happen, right? I know there was some sort of fallback. I know that it went into some sort of Kafka queue, and then it was got from a client, then it was persistent on a database. Now, let's look into the code now. Let's close this one over here and move in here. So now I have this book API, right? So remember, one of the things that I remember seeing here was this ESPN generator fallback. So let's try ESPN. Oh, it's right over here. So now you see how cool this is. Especially, I mean, maybe some of you already know your applications inside out, but in some cases you don't even know that you have to support some application never seen before. And just by looking into this data, you already have some information of what happened on this particular call. So now you can look into the code and see what's happening. Now you'll see, okay, so this ESPN generated fallback, it means, oh, apparently there seems to be some sort of service that generates the ESPN of the book, but that's not available, so it ends up in like some sort of fallback to generate that number. And for that, it actually creates the book and puts it in this channel, which is going to put it on a Kafka queue, right? Yeah, I'm biased. I don't really know what this does, but I guess that you got the idea. And now, well, let's see what else we have. We have this ESPN generator fallback as well. There is the handle. There is this generator over here. Okay, now I see, oh, it tried to call that REST client. That REST client is not available. That's probably another endpoint, another service. So that's why it got into the fallback. And because it got into fallback, it generated that random number and then calls update on the database and persisted the book, right? So now I'm seeing that probably something's missing over here. And of course, now I do a lot of digging and try to figure that out. Now let's do something else. So what's actually happened here is I have another service that generates the ESPN for the book when I created it. So I don't have it running, so when I don't have it running, I actually have some code that does a fallback and creates one as a fallback. Now I'm gonna put the service up and try to create the book again, see what happens. Okay, so let's go here to Swagger UI again. Let's call a couple of executes here. So there was a 201. It seems that the ESPN is a little bit different now. So let's go and do find traces. Now you see a little bit different my trace looks like. So I see that the other one has like 7 spans and only called book API. Now I see that this new one also has book API, also has number API, and only has 5 spans. So now what you see over here is like the trace being propagated across different services, and you're now actually tracing what's happening on the other service. And you're aggregating everything together as a nice piece of information to know what's happening. Okay, again, you're seeing you're tracing /.books. That was the endpoint that I called. That's fine. If I expand this a little bit, okay, I got 201. That's great. I see that I call numbers.generate endpoint, and that's calling another service, right? So this now jumps to another service, and you can see it with a different color that Jaeger put over here. So now I see that it's called numbers generate on another service called number API, of course. I can see what happened over here. So yes, it called get, gave me a 200. That's fine. And now it came back to my application called insert in the book and created the book as it as you will expect. So now you don't have any fallbacks, you don't have any Kafka queues in the middle, right? Those were just as a fallback method if the service was not up. And then you also see here like an update. I think that's an update from Hibernate to update the ID of the book after that was done. So this is just like a couple of examples on how you can use OpenTelemetry. I think, I'm not sure if you got the idea, but at least that was my goal, where you can also use OpenTelemetry to investigate the code of your application if you don't know it. And you see that I invoked the exact same action, which was create the book, and you see completely different results on the tracing data because they also depend on what you call your application. So sometimes when you invoke something on your app, it doesn't mean it's going to always fall on the same tree. It may go on different trees depending on the logic and business of your application. So this kind of allowed me to figure out what's going on in the first case. And then after I fix it, then I see, okay, that's fine. And I collect all the information that I think that's useful. Now, again, this is only 2 services, but now if you start adding like 3, 4, 5, you'll see how difficult this is in the sense that it's hard to debug, it's hard to figure out, but with OpenTelemetry, I believe that's become a little bit easier. And as I'll show you, it's not limited to your application. In this particular case, I call outside things like a database and a Kafka queue, and those were also traced and added to your information. Okay, I think we only have a few minutes left. That was everything that I wanted to show you. So I'm happy to take a couple of questions, but I also want to thank you for all your time and to stay here, especially because that's the last session of the day. You're probably really, really tired. So thank you so much for joining, and I'm happy to take a couple of questions. Sorry? Oh, where is that stored? So it gets stored into so the collector is going to collect the data, and then it will push the data into wherever tool that you want. So in this particular case, it was being stored in Jaeger, because that was the one that I was showing. But you can store it in Prometheus, in Grafana, in Zipkin, whatever tool you use. You can write your own if you want. But I mean, you already have these tools available, and that information is stored over there. And you can also, by the way, you're not limited to one of them. So if you want to actually push that information to let's just say you have like one Jaeger, one Prometheus, one Grafana, one Zipkin, you can push to all of them. So let me actually show here pretty quick. So I think this is probably also interesting. So you'll see there is this hotel collector YAML, right? And this basically is just saying, okay, this is the way that I'm going to collect data. This is how we're going to, this using TLT protocol by gRPC, and the exporter is Jaeger. I'm going to export here. But if you want to add additional exporters, you just add like the Prometheus one, the Zipkin one, as many as you want. And you'll just export to every system. Any more questions? Yes, sir. Yes. I mean, if you want, so one of the things that we did, so in this particular case, you were not seeing the Swagger endpoints being traced because we have a configuration that removes them. Because, I mean, for some people, they're just noise, right? But if you want, you can just trace them as well because they're part of your application. So yes, it also works with Swagger. Yes, sir. Okay, so the question is how tracing works with Kafka and messaging applications, right? So yes. So what happens is there are 2 ways. So if you're using the agent, what the agent does is on the implementation, what happens is basically open tracing creates a context that's always available. So usually it's on the thread local. But once you get into things like asynchronous APIs like Kafka and things like that, what happens is the context gets copied into the headers of the message, so it gets propagated into Kafka as well. And when then it goes out, then the context is again copied to the thread local or some other place that needs to be. So it keeps getting propagated. You can do it. So Artemis also has support for OpenTelemetry. So the trick point here is each tool or each library has different ways to propagate data, right? So for instance, when you propagated the data in an HTTP request, it's easy to use the HTTP headers. If you're propagating the context in Kafka, you have to use it in the headers of the message, which is not HTTP, it's Kafka specific. The same thing for Artemis, right? So, for instance, when you do it on CDI, you just propagate it using the thread local because that's a synchronous API. So, the implementations of OpenTelemetry already handle this for you, so you don't have to worry about it. Any more questions? Okay, I think we're completely out of time. So again, thank you so much for joining. If you have any additional questions later on, you already got the idea of OpenTelemetry, right? So maybe you only pick it up only in a couple of months. Feel free to reach out. My Twitter handle is Roberto Cortez over there. So it's also GitHub, LinkedIn, Facebook, whatever. Mail, robertocortez.yahoo. So feel free to reach me out on any of those media, and I'll be happy to help. Safe travels.